Let's start with the some of the revision point of view. So we had a current carrying wire. So this is the current carrying wire. So around a current carrying wire, we have the magnetic field. As you can see, this one, this is the magnetic field around that one, and we give according to the right hand rule. So this is the direction is given, and you have to imagine always the 3D. So here, here it is going out of the screen. This is the out of the screen. It is into the screen. So the cross is given for into the screen, and this is out of screen. This is out of the screen that we have it. It is into the screen. So this is the magnetic field lines due to the wire. So you have to imagine like this. Now let's learn about the magnetic field around a solenoid. Around a solenoid, you have to be just consider that if they are curling like this, so you can think like this microphone, the in the wire, it is curling. So you have to curl your fingers. Now your thumb is give the direction of the magnetic. You have to curl the fingers like this, and this is the thumb of the right hand. You have to curl your fingers like this, and this is the north, and this is the south. This is the factor affecting the magnetic field strength. So the first factor is, so you can increase. So number of the ways that you can increase the basically the magnetic field strength that is inside a solenoid. The first way is you can increase the current. So increasing the current, you can increase the magnetic field strength. Second way is you can increase the number of the terms, increasing. Third way that you can do that one is by inserting the ferromagnetic substances. The iron is the best one. So insert the iron core. So these are the number of the ways that you can do that one, the magnetic field strength. Let's try this question to understand. The four long straight wire are placed perpendicular to the plane of the paper at the edges of the square. So these are the wires. Cross means the current is going into the screen. Here also it is going into the screen. This is dot means current is going out of the screen. This is also again out of the screen that we have it. So the question is the same amount of the current in each of the wire and the direction is mentioned. Reduce the direction of the magnetic field at the point P at the center of the sphere. So first thing is let's talk about this one. So the first one, so I'm giving the numbering first. So due to the first one, the magnetic field length, because it is going into the screen, so you have to your thumb is pointing out to into the screen, and you have to curl your fingers like this. Or for better understanding, you can take your pen and you can curl your hand like this into the screen. Thumb is into the screen, and you can curl your finger. So if you curl it, so it is these are the magnetic field lines. These are the magnetic field lines. So if you curl it, so it is going down like this. So these are the magnetic field lines, and on the this side is going up. So at this specific point, I have to find it out. So magnetic field direction at this point is I have to draw the tangent. So magnetic field lines due to the first one is like this. This is the B1. This is the B1 that we have. Magnetic field due to the first wire. Now let's look into the second wire. Again, you have to curl your fingers. So around this one, the magnetic field lines are like this. And if you curl it like this, magnetic field lines like this, outward. So at this point, if you look into that, in this point, the magnetic field lines are like this. This is B2. Same amount of the B2 because the distances are the same and the current is flowing in the wire is the same. So B1 and B2 are the same. So you can make it the same length. It's better that you can show the same length of that. This is B2. Now we have the third one. So if you look at this, the third one, it is going out of the screen. So magnetic field lines, you have to show out of the screen or out of the page, and you have to curl your fingers like this. So the magnetic field lines going like this. So if I have to make it at this point, So the magnetic field lines again is in the same direction as B2. So due to the B3 is also in the same direction as B2. So in this direction. So this is B3. So they get added up. The point is they get added up. So again, if you look at this one, let's try to draw it. These are the magnetic field lines and it is going like this. The thumb is outward and at this point again in the same direction as B1. If you look at this, if I had to draw the tangent line at this point, so it is in the same direction of this one. So let me try to give the same direction to that. This is the same magnitude, but B4 right now. This is the fourth one. Now I can add both of them. So I can show that one at the P point, both get added up in this direction. So this is the resultant of B1 plus B4 vector. This is the resultant of B2 plus B3 resultant vector. And now if you learn the parallelogram, you can make the parallelogram like this, or vector law of addition if you done that one. So you can, this is the resultant direction of that. This is the resultant direction of both these vectors that we have it in this specific direction that is on the left side. This is the final resultant direction is towards the left side of